How does vitamin D being fat-soluble affect absorption? Imagine your body as a complex city with various transportation routes and nutrients as travelers moving through these pathways. When it comes to vitamin D, understanding how its chemical nature influences its journey is essential. Vitamin D is classified as a fat-soluble vitamin, meaning it dissolves in fats and oils rather than in water. This characteristic significantly impacts how it is absorbed, transported, and stored within the body. Unlike water-soluble vitamins that are absorbed directly into the bloodstream through the small intestine, fat-soluble vitamins like vitamin D requiring the presence of dietary fats for efficient absorption. When you consume foods containing vitamin D, such as fatty fish, egg yolks, or fortified dairy products, they often contain fats that facilitate the vitamin's uptake. During digestion, fats in these foods stimulate the secretion of bile from the liver into the small intestine. Bile contains bile salts that emulsify fats, breaking them into smaller droplets. This process increases the surface area for enzymes called lipases to act upon, aiding in the breakdown of fats and the releases of fat-soluble vitamins. Once released from the food matrix, vitamin D molecules are incorporated into micelles, tiny, fat-like particles formed during digestion. These micelles serve as vehicles that transport vitamin D through the watery environment of the intestinal lumen to the surface of intestinal cells. Here, vitamin D is absorbed into the epithelial cells lining the intestine. Because vitamin D is fat-soluble, it does not dissolve directly into the watery blood plasma. Instead, it is packaged within chylomicrons, large lipoprotein particles that transport lipids through the lymphatic system. This process allows vitamin D to bypass the portal vein initially and enter the lymphatic circulation, eventually reaching the bloodstream. The transport of vitamin D in the blood involves binding to specific carrier proteins, primarily vitamin D-binding protein. This binding ensures the vitamin remains soluble in the aqueous environment of the blood and allows it to be delivered to various tissues, including the liver where it undergoes conversion to active forms. The fat-soluble nature of vitamin D also influences how it is stored. Excess vitamin D that is not immediately needed by the body is stored in fat tissues and the liver. This storage capability provides a reserve that can be mobilized when dietary intake is low or during periods of increased need. However, because vitamin D is stored in fat, individuals with higher body fat percentages may requiring more vitamin D intake to maintain optimal levels, as some of the vitamin can become sequestered in adipose tissue. In summary, the fat-soluble property of vitamin D means that its absorption depends heavily on dietary fats and the process of emulsification and micelle formation. This characteristic influences not only how efficiently vitamin D is absorbed from food but also how it is transported, distributed, and stored within the body. Understanding this process highlights the importance of consuming vitamin D-rich foods alongside healthy fats to maximize absorption and maintain optimal health.